So last time we talked about graphing quadratic functions using transformations, and in this section we're going to look at using the same processes with other functions as well. First off, we're going to look at graphing the absolute value functions using transformations. We've talked about in the past graphing absolute value equations, and the fact that we're always going to be, every absolute value equation will graph as a V, but not, and we did that with more of a point finding process versus the shifting. Here we're going to look at it using shifting or transformations of the basic. So let's since we're talking functions, instead of writing y, let's write f of x, because this is a function of x, right? This function passes the vertical line test. But so f of x equals the absolute value of x is our basic absolute value function. And if we want to graph any absolute value function, we can do so as a transformation of the points on this graph. Some of the points on the basic, so let's look at our xy pairs, or input-output pairs. If we put, let's say, -2 in for x, the absolute value of -2 is 2. So -2, 2, and we can look on the graph, left 2, up 2, we see -2, 2 is a point on this basic function. If we substitute -1 in for x, the absolute value of -1 is +1. Again, verifying. We do see -1, 1 is a point on the graph, or -2, 2 was. We've got a point also at 0, 0. If we input 0 for x, the absolute value of 0 is 0. 1, 1, 2, 2. Right? If we input 1, the absolute value of 1 is 1. If we input 2, the absolute value of 2 is 2. So I recommend using possibly these 5 points when you're trying to graph other absolute value functions using transformations. And so if you're given an absolute value function in this form, it's going to follow the same basic processes as when we were graphing quadratic equations before. If this value of a is negative, you're going to flip it over the x-axis. If you've got minus a number inside with the x, you're going to move to the right that many places. If it's plus some number, you're going to go left. If you have a number outside, if it's plus the number, you'll move up that many places. If it's minus a number, you'll move down. Okay? But what's important is that you first start with your basic, and then based on what you see in your function, then you'll move your points accordingly. So, looking at this graph here, we have f of x equals the absolute value of x minus 4 minus 1. So when I'm looking at this, I say, oh, this is an absolute value function. I see these absolute values, and so because it is an absolute value function, I can use transformations of the basic absolute value function to graph. Okay, so anytime you're graphing with if you're trying to graph and you're doing so using transformations, you always have to first sit and think, okay, first off, what function will I start with? Okay, and that depends on what you see going on here. Since this is an absolute value function, we're going to start with the basic absolute value. So that's the f of x equals the absolute value of x. And you know what, just for clarification, instead of calling it f, let's call it g, so we can label what we have. So right here, what you see, I've already placed G on your graph, right? This is the graph of the basic. It has points at negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Okay? And then, once I know what I'm starting with, then I'm going to take that graph and do my either rotations if necessary and shifts if necessary. So looking at this, I do not have a negative value for A, so I don't need to do any flipping. Okay, so since the value of A is just positive 1, I'm not going to do any flipping or stretching, which we'll talk more about. We're not talking about doing any stretching here. So we know we're not going to be doing any flipping. If we had a negative up here, then we would be flipping or rotating about the x-axis. Inside, with the x, if there's the number inside the absolute value or the square or whatever type of function you're dealing with, that's a left or a right shift. Since it's minus 4, that tells me I need to move all the points. So first of all, no flipping. Second of all, I'm going to shift my points to the right, because it's minus 4 places. Okay? If this had been plus 4, I would have shifted them to the left 4 places. And then finally, I look to see if I need to move it up or down. And because there's a number here, I know I need to move it up or down. Because it's minus 1, I know I go down 1. If it had been plus 1, I would go up 1. So I need to then move every point down 1. Okay, let me change my ink color for this. So there was no flipping, but I do need to shift all my points to the right 4 places and down 1 place. So let's start with this point here. So we'll move it to the right 4, 1, 2, 3, 4, and down 1. And this point then moves to that place there at 2, 1. Okay, that one's done. If we move this one right, 1, 2, 3, 4, down 1, that's gone. This point at the origin, right, 1, 2, 3, 4, down 1, that point's been moved. This point, 1, 2, 3, 4, down 1. And finally, 1, 2, 3, 4, down 1. And so now I have shifted those points over, so the graph of F is going to be this V here. Okay? So I can take and make the graph F, I can graph F by taking G, moving it to the right 4 and down 1. Okay? Square root functions. So if you're trying to graph functions that are square root functions, you would want to start with the basic square root function, which I have graphed for you here. Please note that this is a point. It does not continue. There's no arrow here, though there is an arrow on the end over here. Okay? The reason for that, if you think about your square root function, if you try to input negative numbers in for x, let's say, negative 1, then you'd have the square root of negative 1, which is a complex number. And you cannot graph complex numbers in the real plane. They don't exist here. Okay? So your square root function I cannot input negative numbers in for x for this basic square root. If I try to input negative numbers, I'll have a complex output, so there are no points. I can, however, input 0. Inputting 0 for x, the square root of 0 is 0. So my starting point with square root functions is this 0, 0. Okay? And then looking at some other, it looks like 1, 1. If we check the math, if I input 1 for x, the square root of 1 is 1. If you input 2, there is a corresponding output, but the square root of 2 is some crazy irrational number. So in terms of shifting, it's going to be easiest if you, when you do your shifts, if you work with lattice points, points where both the x-coordinate and the y-coordinate are integers. So I would pick 0 works good because the square root of 0 is 0. 1 works good because the square root of 1 is 1. 2 doesn't work so well because the square root of 2 is an irrational number. 3 doesn't work so well because the square root of 3 is also an irrational number. 4 works well because 4 is a perfect square. And if we do the square root of 4, we do get 2. Let's verify with the graph that we see. So if we go right 1, 2, 3, 4 up 2, we do see that we do have a lattice point at 4, 2. 9, 3 would also be a good easy input-output pair to work with. So it's nice if you're working with the basic square root if you use perfect squares as inputs for x. Okay, so anytime you're wanting to graph a square root function, you want to start with points that are on the basic and do shifts as necessary. Okay, just the same as before with the x squared, with the absolute value. If this is a negative number, you're going to flip it over the x-axis. If you have minus a number inside with the x, you're going to move it to the right, h places. If it's plus h, plus some number, you're going to move it to the left. If you have plus k, you'll move it up. If you have minus some number, you're going to be moving it down. Okay, so here, and you know, I should have taken those off because when you look at this, you're not going to know which function that you're not going to know or see that anywhere. So what needs to happen in your head is you look at this function and it says graph f of x equals the opposite of the square root of x minus 3. And so the first aha moment you're going to have is say, oh, this is a square root function. So to graph this square root function, I can transform the basic square root function. Okay? Or move points on the basic in a manner that is consistent with the numbers or the values we're seeing in the function itself. Okay? So our basic we're going to call g. So g of x equals the square root of x. That is our basic, and that is what I've graphed for you here. Okay? And we just discussed good points to use: 0, 0, 1, 1, 4, 2, and 3, 9. Right? 0, 0, 1, 1, 4, 2, not 3, 9, 9, 3. 9, 3, right? Input 9, the square root of 9 is 3. And then I go to my function f. So what I'm trying to do by graphing using a transformation, to graph f, I'm taking g, because this is a minus here, I'm going to flip g, oops, over the x-axis. And then the second thing I'm going to do, because we have this minus 3 inside the square root with the x. Okay, if it's in with the x, that's left or right. If it's outside, that's up and down. So minus 3 inside, I'm going to move my g right 3 places. Okay? So flipping G over the x-axis, let me change my ink color. I'll go purple. So if I flip it, when you flip or rotate about the x-axis, you leave anything that's on the x-axis fixed, and then you rotate it just like a rotisserie. So this point is going to go here, this point will go here, and this point, it was at +3 and now it's going to be at -3. Okay? So this is what the opposite of G looks like, or that's what it looks like when I take my G and I flip it over the x-axis. So this part is done. Okay, now I want to take my G, or actually I should say take the opposite of G and move it to the right 3 places. So all of these points I now need to move right 3. So let me I'll go black here. So this is no longer, right? And I've got this graph here. So move to the right, 1, 2, 3. Move to the right, 1, 2, 3. Gone, gone. Take this point to the right, 1, 2, 3. And take this point to the right, 1, 2, 3. And so, this is my fixed point. Stays, it looks exactly the same, just now shifted to the right 3 places. So this is the graph of F. If you can even see that. Also, we need to state its domain and range. So my domain, I always scan left to right. I'm looking for values of x that are in my ordered pairs. So the smallest x value is the x coordinate of this point, and then the largest would be going out towards positive infinity. So right 1, 2, that's 3. So my domain is every x value consists of every x value from +3 to infinity. For range, when we're trying to determine range, always do lowest y value to highest y value. So I'm looking at my function and it does come down here. So I do have values from -infinity all the way up to the y value of this point, which is 0. So the range of this function is every real number from -infinity to +0. Okay? Again, we have another square root function. So because I look at this and I see a square root function, that's how I know to start with this one. Okay? Hopefully you're getting that, because that's a big deal. Okay? So because f is a square root function, we need to start with our g of x equals the square root of x. That is our basic square root function. And that's what I have graphed for you already. Right? We've got points at 0, 0, 1, 1, 4, 2, 9, 3. So those are some easy lattice points to work with. When I look at my function, so now I'm going to try to decide what do I need to do to G in order to make the graph of F. And looking at what F says, there's no negative here, so I don't need to flip. There's no number inside with the x, so I do not move left or right. I do have this +3 outside of the square root, so that's how I know I need to shift all of my points up 3 places. So to graph F from G, all I have to do is take G and shift all points up 3 places. So using my lattice points to help me, I go up 1, 2, 3, gone. Take this one up, 1, 2, 3. Take this one, 1, 2, 3. And this one, 1, 2, 3. And so it looks the same. Just remember, we're really taking all of these points and shifting them, though we're only highlighting some lattice points to help us get our shape. So this is the graph of F. So my domain, as I scan left to right, I don't have any points back here. No points, no points, no points. Here I have a point. The x-coordinate of that point is 0, and then I have points all the way over to positive infinity. So the domain is every x value from 0 to infinity. The range, we have nothing down here, right? Remember, there's no arrow. It does not continue on down. So nothing, 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 nothing. The y value of the lowest point is 3. And then it does continue to rise up forever. So the range goes from positive 3 to infinity. We have another, so we want to graph this square root function. So because this is a square root function, I'm going to start with the basic square root function. So here is my g. Right? Remember, we've got points at 0, 0, 1, 1, 4, 2, 9, 3. To those, because we have this negative here, we're going to flip g, because we have a plus 1 on the inside with the x, plus on the inside that's left one place, and then the minus 7 here, we're going to then move all points down 7. So let's do the flipping first. So again, if we flip, we're going to take this and just rotate it about the x-axis. So leave anything fixed and then just rotate it around the x-axis. Doing so, this point will be down here, and the 3, 9 will be now, the 9, 3 will now be at 9, negative 3. So that's what it looks like when it's flipped. And then we need to go left 1, down 7. And write 7 with those points. So left 1, down 1, 2, 3, 4, 5, 6, 7. This one, left 1, down 1, 2, 3, 4, 5, 6, 7. Left 1, down 1, 2, 3, 4, 5, 6, 7. Left 1, down 1, 2, 3, 4, 5, 6, 7. And if ever you doubt that you have the right points, there's no reason you can't verify that the lattice points that you have here are input-output pairs for this function. So when I'm looking at this, I see I have this point at negative 1, negative 7. So it should be that if I input negative 1, if for negative 1, negative 7 to be a point on the graph, it has to be that inputting negative 1 for x corresponds to an output of negative 7. So if I input the negative 1, simplifying that, the negative 1 plus 1, that's 0. The square root of 0 is 0, and negative 0 is 0, minus 7 is negative 7. So it is true that if we input negative 1, that the output is negative 7, and that corresponds to negative 1, negative 7 being a point on the graph. And you can do that for all of these points if you aren't sure if you've done your shifting correctly. Okay. Cubic functions. So cubic functions, we've got this something cubed going on in our function. And if we're wanting to graph cubic functions, we're going to use the same process, But the basic function that we'll start with is the basic cubic, which I have graphed for you here. Some points that are on the basic cubic, we look at input-output pairs. If we input -2 for x, -2 times -2 times -2, that output is -8. If we input -1, the output is -1. Input 0, output 0, input 1, output 1, input 2, output 8. Right? If you put -1 in, -1 times -1 times -1 is -1. Put 0 in, 0 times 0 times 0 is 0. Put 1 in, 1 times 1 times 1 is 1. Put 2 in, 2 times 2 times 2 is 8. And you can see -2, -8 is a lattice point on this graph. -1, 1 is, 0, 0, 1, 1, and 2, 8. So these are the points that I like to use on my basic cubic when I'm trying to graph other cubic functions from the basic. So here, graph f of x equals x to the third plus 8 and state its domain and range. So what needs to be going through your head is, oh, I see this cube. So to graph this cubic function, I'm going to start with the basic cubic function. Okay? So to graph this function, this cubic function, we will start with the basic cubic function. Which is g of x equals x to the third. The cubing or the cubic function. Okay? So input-output pairs, we already discussed. If you input -2, the output is -8. If you input -1, the output is -1. 0, 0, 1, 1, 2, 8. You know, I myself usually cut out these last 2 points, but I want to caution you in doing so. The issue that people have when they only put those 3 middle points is that they then say, oh, I can just connect the dots and make this diagonal line. That is absolutely false. So having that point at 2, 8 and that point at -2, 8 hopefully will keep you on track so that you realize, oh, hey, wait a second, no, I have to curve it because cubic functions have that curve shape. So this is the graph of my basic, that's G. So to graph this cubic, there's no negative, so I don't need to flip. There's no number inside with the x, so I don't need to move left or right. And then this plus 8 is the constant out here. That tells me I need to move everything up 8 places. So to make this graph of f, so to graph f, I am going to shift G up 8 places. Okay? So all points on G up 8 places. So I'll just move my lattice points and then connect to show I'm shifting all points on G. So up 1, 2, 3, 4, 5, 6, 7, 8. Then if I move this up 8, it will be at 0, 8. From 1, 1 up 8 will be at 1, 9. And 2, 8 up 8 will be at 2, 16, way up there. So this is the graph of f. It's not beautiful. I apologize. It's hard to write on this thing. I do expect your graphs to look much nicer. If we have domain We also need to find domain. So again, this is not vertical, and I know it looks pretty sharp going down, but it is always going to continue to go in and out. You know, you can input, if you input -4, -4 times -4 times -4, that would be -64, -64 plus 8. You know, we do have points, but they're just, this is always going out, but it is very steep. Okay, so because of the fact that it is moving out in both directions, it is going to be that the domain is every real number from -infinity to +infinity, and also that the range, bottom to top, I'm looking at F, which is the red. We do have every value from -infinity, all real numbers, -infinity to infinity in the range for this cubic function. Okay, so here I'm graphing a cubic. So because I'm graphing a cubic, or to graph this cubic, I'm going to start with the basic cubic function. Okay, so I'm going to start with g of x equals x to the third. So that has points at 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. Right, that's what my g looks like. Sorry. And then to make f, I'm going to take g. We've got this +1 inside here. Because it's +1, I'm going to move all of my points to the left 1. And that -4, I'm then going to move all my points down 4. So every point, left 1 and down 4, and that will be the graph of f. So left 1, down 1, 2, 3, 4. Here, left 1, down 1, 2, 3, 4. Left 1, down 1, 2, 3, 4. Left 1, down 1, 2, 3, 4. And then finally left 1 and down 1, 2, 3, 4. I apologize. It should look more like that, but I'm trying to get all those points. So here we have the graph of f. And so the domain, and as you can see, regardless of the cubic function, the domain then is always going to be -infinity to infinity, as is the range. Okay. Alright, and I guess that's all I have for you. Let me know if you have any questions, and just make sure that when you're looking at the graph, that if you're trying to graph a function, you need to know what type of function it is first. Is it quadratic? Is it absolute value, square root, or cubic? Because the type of function you're trying to graph, that decides which function you start with, whether it's the basic quadratic, the basic cubic, the basic square root, or the basic absolute value. So let me know if you have any questions. Good luck.